Okay, Timo. So we sit together today to talk a little bit about Google Analytics for why you may or may not want to use the interface directly. Some people are turned off by it, turning to other ways of working with the data, for example, in BigQuery directly. So what's your take on when would or would it not make sense to actually jump to a full-fledged data model? When do you need it? When could you maybe get away with something in between working with the interface directly and turning to a full-fledged data model? What's your take on this?
Thanks. That's a good introduction. As usual, life is more complicated than simple solutions. So let me take some time and let me share the obvious whiteboard to discuss these things.
Sure.
So just a second. When do I need a data model? I think there are different scenarios. So what you can see is like when you see right now people exploring BigQuery data from Google Analytics 4, or let's say GA4, so that we don't always have to say it in full name. So when you see people describing how they approach these things, they often do ad hoc queries. So what they want to do is they have a specific kind of questions they want to answer, and they figure out the SQL for that, and then they run the query, and then they answer the question and maybe print a chart or do something, consolidate everything, send it around, and then people are happy. I think, let's say, so if you put down like this,
sounds easy.
That's
in the first.
Yeah, in theory, it sounds easy. Yeah, that's right. So there's everything. Let's say the problems are different thing, but it's definitely manageable. So the good thing is like you already have enough good resources. So there's I think it's called GA4 SQL project, where let's say someone really sat down and created a generator for SQL queries. So you can give in, okay, I want to have this dimension, I want to have this metrics, and so please give me the SQL code for that. And this SQL code then basically runs on top of your original raw GA4 data. And the nice thing is because like it's one schema, everyone has this kind of schema, of course, like this generator works because it will also work on your thing. So I think for ad hoc, we don't need a data model. So let's move it over here because it's not relevant here. So it's super cool to just write a query and figure things out. I think this is totally fine.
Just maybe to clarify, when we talk about ad hoc SQL queries, we talk about launching them or running them against something like BigQuery, for example, once you already synced your data to it, or where would they materialize?
No, that's a good thing. So it's basically, in most cases, I would say it's BigQuery. So Google Analytics 4 exports data to BigQuery only. And this will not change because both is Google products. So Google will not offer that you can, for example, export directly to Snowflake. Maybe they won't. So it's pretty unlikely. So most of the setups are still like in BigQuery. There might be cases, and so we did projects where we did the same thing. So where we took the data that was a BigQuery and then we basically piped it to a different kind of data warehouse. So because, for example, you work in Snowflake and then, of course, you want the GA4 data also in Snowflake. So then you might create a pipeline, bring it over and so on. In this case, these, at least like the query generators, might not work because like usually when you pipe the data from one system to the other, you might already apply some kind of transformation. So maybe you make a selection what you actually want to load in the other system because you know that you don't really need everything. So then it will not work. But let's say in 95% of the cases, also like from the examples that you see online, it will be on BigQuery to do these things. And today we stay in BigQuery because it's quite comfortable and BigQuery is a good system to do all these kind of things. But coming back to your questions, we have a talk, which let's say, I think this is covered, but there is definitely an evolution in there. And the evolution is often like this. You might start with some ad hoc queries. So you generate some insights, you maybe then create some charts, you give it to the specific kind of teams. And then the nice and scary thing in data happens is like people like what you do. So first of all, it's great that people like what you do, but they expect more. This is normal. If you do good stuff, people think, hey, there can be more. So there might be that people asking, look, we have these kind of ideas of this kind of reports that we want to have, and we want to have them regularly. We want to have them updated and so on. So you basically, at some point, you come into a situation that you basically have to deliver something constantly in bigger extent. So it might be not that you don't deliver one chart or one analysis, but you might be that they're asking, hey, we have this kind of idea for a daily report that we want to see. So the requirements on the business side are growing, and you have to find a way how to serve them. And of course, you can try to cover this with ad hoc queries along the way, but there's a natural point where this is basically exhausting and not scalable anymore. So you have to find a solution how to scale it, how to automate it. So in the end, it's scale and automation that drives you to the point to do a data model I know enough people who would also like not just scale and automation, who would also put in another thing, and this is data quality.
Exactly. This is what I was going to say, that it's easy to produce something, but to produce it on a consistent, you already mentioned that, consistency, but also consistency, not just in the pipeline, but in the quality. And the more you need to handle, and once you're on the hook, obviously, with this type of stuff, as you pointed out, then it's really hard to do, I think, from my experience.
But the good thing is like that you really know that there's an inflection point. So it's like always, it's not, of course, if you have experience. So when I usually build setups, I rarely do ad hoc queries. Sometimes if I want to get a feeling for the data, I usually end up to already build, let's say, a very bare or very easy, simple data model, because I already know that at some point we will get there. And so I can do the, let's say, the foundation already.
Yeah, the scaffolding, basically.
But this is normal. If you have some experience, if you talk to someone who's writing, I don't know, Python code for 10 years, when they develop an application, they're also like, just by nature already put the building blocks in place that this thing can be easily broken apart and put in different kind of things.
Muscle memory, basically.
And so, but it shouldn't put you under pressure to immediately start with the data model. But there is a point. So as we said, like there's a point when scaling automation can happen, when you want to ensure data quality, and I want to even like test data quality at some point. And then of course, like to establish a specific kind of consistency, then it's the point that you start to think about the data model. The tricky thing, which you should definitely keep in mind, is like when you start to Google for data modeling or data model, or if you follow people on LinkedIn about data modeling, it can be pretty mind-blowing because like it's a huge topic and it's a complicated topic. And it's a very, opinionated topic. So you will see people who basically die for a specific approach to data modeling, because they invested a lot of time into this to understand how this works, and they did a lot of projects with this, so they're really expert in this kind, often in one approach in data modeling. And as you already hear it, there are different approaches in data modeling, and we don't go into them today because this was basically would not really help us. But let's say there are different approaches, and the big question is like, what would you take to start with a data model? And it's not really easy to answer, but I try the simple version. In the end, data modeling is always layering. So in the end, you build up different layers of stuff. And so why do you need a data model? You need a data model because like the way that data is loaded into a data warehouse is, I would say, in 98% never in the shape that you can use it for, let's say, creating a dashboard with it or doing some other kind of application. So there's always a disconnect between how source data arrives and how you basically provide the data for other applications to work with it. And so just because like, how should Google know what you want to do with the data? And even if they would know, there would be 2 million use cases that people have, and they cannot support 2 million use cases. So they have one way how they bring the data in. And this way, how Google is getting the data into BigQuery is optimized for loading. And you will see, and you might be one of these who's complaining a little bit why it looks so complicated, the kind of data that they put in. But the reason for this is pretty simple. It's optimized for loading. It's optimized for that your event schema can change, because it can. You will extend it. You might remove things and so on.
Basically optimized for robustness and schema drift, schema changes, being like keeping the bare bone really solid, basically.
Exactly. So you have the first layer, which is basically like the loaded data. And then you might introduce, but you don't have to. So you might introduce a second layer, which is like for storage. So I always take the example, let's say you're a manufacturer, so you produce things. So loading means like there comes some trucks to your factory and they place things on your loading ramp. And it comes like the people where you buy the stuff are packaging these things. So they package it in their system because this is how it works for them. And so they put it on your ramp. And then your first step is to take this stuff and then put it into your system that you use. And so there can be very sophisticated system how you store incoming goods that you want to work with. And this is the same with data. So you can have a really sophisticated system to handle storage. Let's say there are very sophisticated modeling approaches like data vault or anchor modeling, which are optimized for any kind of, let's say, weird use cases, how data can change, but you can still store it in a proper way that you can work with it. As these systems are good if you get 200 different types of data and you have at least like 20% where you have constant change in the stuff, how it arrives and so on. So the system, how you store things, of course, like is dictated by in which kind of shape and how much data you get to do it.
But it's an important distinction. I think that some people might not really be that aware of that loading just gets you to the ramp basically. And after that, it's your way of how to organize, how your shop is basically organized, what you need, how often you need it, how often it changes, how you set up your storage layer basically.
Yeah, and it can be so like in most of the setups that we work with, they are pretty straightforward. So our storage is also like it's often pretty simple because let's say we have 5 or 6 sources. So what we do on the storage layer is like we align things. So for example, we give timestamps the same name. We give, let's say, cost data the same name. So we align naming a little bit, we align formats. So it could be, for example, that sometimes it comes not as a timestamp, but maybe as an integer or so. Like we have, let's say, a common standard, let's say what kind of formats we have. And the major purpose for that is like to make it much more a no-brainer later on when we work with the data that you don't always have to think about and always have to change stuff. So we change it once, then it's pretty clear and it's easy to work with. I think this easy to work with is a very strong and important paradigm here. So like all the stuff that you do, especially like in the beginning, you do to make it easier for future or let's say further steps down the line to handle this stuff, not to do everything.
That's a very good point that you're making. I just realized I would self-qualify rather as a developer than a maybe data pipeline guy. And in the developer domain, there's the concept of developer experience. And what we need here is the data modeler's experience. It needs to be as good of an internal experience to work with your storage data or your data basically in top level. You should invest in making this as easy as possible and as not spending like mental overhead thinking about or overthinking things before doing things.
Oh, 100%. And if we take the assembly line example again, so for example, we get some stuff, we have it on the ramp, we put it into storage, and then for example, we don't unpack the stuff. So stuff is still packed. Once it gets to the assembly line, people on the assembly line still have to unpack the things. This is super annoying. It will cost, let's say, significant of productivity if they have to do it. It's a much better approach to basically prep everything already in storage so that when it's pulled from storage, that it's basically ready to use, let's say, to the best degree possible. And this is the same thing what we do with data here as well. So we prep the data that it's ready to use, and it doesn't really need a lot of work when we work further with the stuff. So we move one layer down. Then you might have a layer which is, let's say, includes business rules. And this sounds pretty generic, but we will show later an example to understand it better. But there's always like the case, so when you build a dashboard, you show some metrics. Most of the metrics include some kind of business rules. If you have a metric like revenue and you go to 10 different companies, you can even go into a company and ask 10 different people in a company. The definition for revenue might be different across all.
It will be different.
Because, yes, it is. Which is natural because revenue is a definition metric. So you have to define it. So you have to say what goes into revenue and what doesn't go, because like you might deduct things. You might filter out specific kind of customers and so on. This is a business rule. So it's a definition what you do. And so in the best case, like in your data model, you have one place where you apply all this kind of business rules so that when the data then is ready for, let's say, presentation, which I wrote here, or application or whatever. So like you use the data somewhere, like in a dashboard, or maybe even like in an ML application and so on, that the business rules are already applied as far as it's possible so that you don't mix up things. So not that you have 6 tracks where you do the business rule always on the presentation layer, and in 5 models, it's in the right state, but in one, because someone forgot to update it, it's still, let's say, on version 2.3 and not version 3.5 that is now basically the new ruling, and then everyone is wondering why the numbers don't match up. So this is definitely something that you want to do as early as possible, and at least like my recommendation, in a central place. So if business rules are scattered in, let's say, more than 3 places, usually this is like already a recipe for disaster, because like in the end you will have metrics where no one can actually explain how this metric comes together, because there's still some calculation and some kind of step that no one is really like aware of, because like it's happened somewhere hidden in some kind of SQL query that runs somewhere where no one really knows.
It's basically single source of truth in a bit of a wider sense. It's not like it needs to be defined just in one way, but it at least needs to be defined in one layer or one domain where you know if something changes or needs to change, this is where the change should happen, and the presentation layer should not be affected by it, or should not care. It should just use whatever is defined by the business logic, basically.
And now comes the big question is, okay, what kind of data model should I apply for Google Analytics 4 data? General spoken, any kind of data model you can use. You can read up anything about star schema and so on, and if it fits for you and it works for you, just go with it. So the data model that I will use in the video is something that I use heavily because this kind of data modeling approach works extremely good for event data, especially designed for event data. Google Analytics 4 is pure event data. You have page views, which are events. And then, of course, like you have all the other events that you might send into GA4 to map out the behavior of users in your application. This is like an activity schema is optimized for this kind of thing. So this is like why I use activity schema for GA4 data and also like for all the other kind of event data.
So what exactly is it, though? I think there might be people that might or might not be familiar with the term of what exactly an activity schema actually consists of or is.
So let me explain it. So when we take this, what it is mostly, it depends a little bit. But let's say the definition of activity schema is mostly about the business rule part. So it's like how we apply specific kind of rules to the data that we can then later use to create, for example, specific kind of presentation tables that we can then use, for example, as a dashboard. To some degree, it also has something with storage, but I leave it out because this is more like a minor part. Mostly it's about business rules. But what it does, and this is why I like to use it, like it makes this business rule part extremely simple, because in the end, when we look into data, not in data, but when we look into event data, in the end, by default, it's not really complex when it comes to business rules. So in the end, it's mostly we have to make a decision which kind of event data is important for us, and then we can construct it. So what you do in Activity Schema is basically like you construct activities, which are in the event, let's say, a qualified version of an event. So we construct activities and we put all these activities into one table.
Can you maybe give just maybe one or two examples of what an activity chain or what an activity would be like?
In the end, like it can be anything that is happening in your application. So for example, let's say we are Jira, our most beloved task management tool. So for example, task created can be an activity. It can be that, for example, we already track task created as this in GA4, but it can also be like that, for example, in GA4, we do task form submit, for example, as event. And so here we have the chance to basically take this and bring it into a form that we know would make sense later to work with it. And so we qualify events and we select events. So most of the setups that I work with, I don't pick all the events that I get from GA4. I just pick the ones that I know are now important for kind of reporting. And so I make a pre-selection. And this, of course, like it's valuable because I want to reduce the amount that people have to digest if they want to work with the data. So again, developer experience.
Yeah, got it. Thanks.
And what I do with activity schemas, I place all these events again into one table. So this is pretty close to how the data arrives from GA4. So GA4 is the same thing. So you have one table with all the atomic events. The big difference here is it is a very small schema or table. You have the white tables. So white tables means like you have a lot of different kind of columns. The way how GA4 stores the data, just because like they optimize for storage, is pretty wide. And it's also like pretty deep because like they use a lot of nested data. What we create is the opposite of it. So we make a very flat and small schema for two reasons. First of all, it's better for query performance. So first of all, it can query faster. And when it queries faster and it doesn't consume so much data, in the end, of course, like it's much cheaper to use. So if you always scan everything like what GA4 is giving you, then of course, like you can create more costs because like this is how BigQuery is calculating the costs. So based on the data they have to go through to present the results. So we make this part better. And the second part, this is even more important for me, is we reduce significantly the complexity to work with this kind of table. So one problem that I often have in other data modeling approaches is like when you step away from the model, let's say for 4 weeks, because you work on something different, and then you come back. In most of the other modeling approaches, I definitely need half a day, sometimes a day, sometimes even 2 days to get an understanding again how to approach a new task in there, because I have to understand the whole schema again. And so in activity schema, I show in a second how the schema looks like. In activity schema, you always have the same kind of schema that you use. So you always have the same column names. And in the end, it's just like a very low number of column names. So I think, so it depends how much you will use from, let's say, the schema, let's say between 8 and 10. 8 and 10 columns. So this is extremely straightforward. So when I work on an activity schema modeled data model, my time that I can start to pick up things is usually 5 to 10 minutes. So it's super fast because I always know what I'm looking for. I also always know how to extend something because there's just one way to extend it. So I don't have to come up with creative new extensions. There's just one way how I can extend things, but it's still flexible enough to do it. So this makes it, at least like for me, so attractive to work with it.
Sounds completely reasonable and a good way. And eager to see it in real life, because how the data structure looks like, that's still like a bit vague to me, but I get the feeling. And again, it reduces mental overhead and mental switching costs. I think this is apart from reducing the cost on running the SQL queries against the entire BigQuery. I think this is one of the two main points here, as you highlight.
Yeah, we maybe let's say as one last thing, and then we move over to actually see something. Another thing which we haven't put down here, besides everything else, costs can be a problem at some point. So if I always run very complex queries, and for example, someone in my team asks, okay, I want to have it for the full year. So you have to go through the whole year of data. Let's say you're a very successful app. So you produce a lot of data because a lot of people are using the app. Costs become an impact at some point. And there's like a simple rule. So the more data I query, the more costs I have. So the first rule of reducing costs in BigQuery, or any kind of, let's say, data warehouse system, of course, like is reduce the data. And this is definitely something that we do here with activity schema. So we reduce the data to, on the one hand, make it cost efficient, and on the other hand, as you said, like to get rid of mental overhead. And this is a good word. I should keep it in mind. So it's definitely good. So enough talking and just showing some errors. So let us go a little bit into the data. So I prepared a little bit. So we are now in BigQuery. This is a live data set. So this is the data set that we use. It's generated by data from deepskydata.com, where you might watch this video already. It's a very simple setup. So we don't really send any kind of custom events, because with activity schema, we can construct these events later. So this is another benefit. So it frees us a little bit up from the pressure to always implement stuff on the front end. So we can make this decision later. Not always, because there might be some stuff missing. But to get started, you can already derive a lot of things that come in. So right now we just get the standard events, as you can see here. So we have first visit, which is the standard GA4 event, session start, which is the standard GA4 event. And this is like how GA4 loads the data into your database. And this part here is very specific. It's also like the engineers at Google, they love the stuff that they built for BigQuery. So someone thought, hey, we have this cool thing that we can do nested stuff, which is this, like this is a nested array in the end, or nested rows. So let's apply this here too. Is it a good idea? Yes, maybe not. So put it like this. I work with a lot of data source data, and you rarely come across this one. Maybe it's the best way to load data, maybe not. But in the end, you cannot control it, because this is the typical thing in every data setup. People deliver the stuff as they deliver it, and Google delivers the data like this. So
and deal with it, basically, right? You need to find your own ways around it or with it.
And the good thing is this already, we will see it in the SQL query in a second, this already makes a really good case for data modeling. Because important data, for example, like page location, which is in the end page path, is super important for us for a lot of things, but it's nested. So we always have to unnest it to surface it, which blows up our queries significantly and also makes the query pretty unreadable. So coming back to developer experience, it's definitely a good idea to, let's say, align everything in the first step, so that later we don't really have to think about it. We can just work with it as, let's say, a normal flat table. So this is what we do. And you can also see, like we were talking about wide. This table is quite wide.
Maybe the nesting structure is just ensuring, this is just Google ensuring to make money, because you always need to do stuff, right? To reach into the nested structure.
It's possible. In the end, it's a commercial company. I would still believe this is like typical engineering where they know, hey, we have the tools. It's not supported in any kind of other database. So we just showcase what we have. Maybe it's also like to showcase. In the end, it's quite interesting because BigQuery, for example, never had, at least not in the beginning, they didn't have a JSON column or JSON type, but they introduced it now as well. So it might have been a better idea to put all this stuff just in a JSON type.
Yeah.
Because like it's much easier accessible. And you will see we will work with the JSON type later in our data model as well. But at the time when the GA4 data loading was constructed, the JSON data type was not available. They went with their crazy stuff. So it is what it is. As I said, like you cannot choose how the data gets delivered. And I can tell you, if you really dive into this topic and you work with other data sources, this will always be a painful experience.
Yeah.
The first glance that you get on the data, new data that you get somewhere, will always be painful. Because like you will always have these moments where you think, why did they do this? As one side note, so for example,
my life so hard.
Right, everyone's life in the end. So for example, if you work with Google Ads data, the costs are in a micro format, which no one else on this planet is using, but Google Ads is using it. So you have to figure out how to transform it from a micro format into normal currency data. It's one of the fun things to work in data. Okay, let's work with this. So we want to get from here. So we have here our loaded data. So first of all, we want to improve the storage. And so we do both in one step. So we improve the storage and we want to apply some business rules. And so we do it in one step. And so how do we do it? And then like we write SQL queries. So the first approach, which is always good, is like just run some SQL queries against the data to basically develop the kind of model. We would talk in the end for 2 or 3 minutes a little bit, what kind of options do you have if you want to go beyond, if you want to productize it or productionize it and to make it more stable. But starting out with just writing queries is definitely a good idea. So some basics for people who are not super familiar with SQL. So for example, if you use GA4 SQL generator, they work a lot with nested queries, which I personally dislike. I cannot tell you how much I dislike it, because they are super hard to read. There are scenarios where they have, I think, even some performance benefits, but in most of the cases, it's not really such a difference. And what I use here, and this might be something that you don't know yet, when it starts here with the with statement, I use CTEs, which in the end are, so if you have a programming background, are basically like functions. So we generate a result here in this kind of block, and then we reuse this result and we put something on top of it. And then again, we put something on top of it. So we basically stack different kind of, let's say, data transformations on top of each other.
You're programming in SQL in a way. Like in a low-level way.
Yeah. The big benefit of it is like the readability. So it makes things a lot easier to read because like we have logic steps how we transform the data. And so we have the logic steps in here so that you can see it. When we go through, in the first step, and this is what we do in storage. Let's say the first 2 steps were usually something which I would say is on the storage layer. In this example, we do it in this query, where we later look into scalability options. I will show you, for example, in dbt, I have these first 2 queries or CTEs I have in one model. And for example, already can then materialize this data as my storage layer data. So what we do here is we just pick the stuff that we need. So this is something which is very important when you work with this kind of data, is that, and don't be so sorry, we see the syntax error. This is like the problem. BigQuery knows things that I want to run what I just selected as a query, and this of course would not work. So it's expected. We pick the things that we really need. As you can see here, we have a lot of stuff that we can choose from. But in the end, what we just want to do right now, we just need these kind of data. And this is my generic rule. When you build these kind of models, start with to take just the data that you need for this first step to answer things. Don't come up with, what could we need in the potential future? Because then you will basically over-design it. We always want to stay small as possible. This model is pretty good to be extended. So you will not close doors when you know, for example, say, look, geographic information is not important for us right now. There's no problem to introduce it later. So you can just kick it out. So for example, this is definitely something. So I don't use it. I, for example, could now remove it because we don't really need it.
That's a very good point. I think for developers, I think this is, again, a point to put a pin into it, because it, again, adds to developer experience. You ain't going to need it. And premature optimization is like the death of whatever the quote is. I think this like ties in with this perfectly, because I think lots of the stuff that we see built out is driven by the fear of if you ain't gonna put it into the initial draft of your schema or whatever, your architecture, that it's then lost because you cannot bring it back. And you basically show here that no, you can start simple because it's really easy to extend later on.
And I can just show later a little bit how you can extend it. And so it's really easy. But keep it in mind. So just start with the things that you need. I do one thing already here on this kind of layer. I calculate, let's say, foundational things. So for example, at some point, we don't need it right now because I don't really use it, but we might need a session ID. So I just did it for the sake of the example. So for the first version that I just working on, it would be ridiculous. So of course, I would keep it out. But there's definitely a stage where I might need the session ID, and I would calculate it here as well. And here you can see this is how you get this kind of data when you need to unnest things. So this is to work with this stack data, because I need the GA session ID. So I have to create this kind of, let's say, it's a subquery. I think it's not technically a subquery. I don't know. But I have to create this to get the value from the nested kind of data. This is why it totally makes sense to unnest everything that you need already on this kind of level to just make it available. So I prepare everything, then I basically, here for example, then I construct a real session ID. So because the GA session ID, at least what I read in the documentation by itself, is not unique. So I combine it with the user pseudo ID, which is in the end the cookie ID that Google is thinks. And so based on the documentation, this should be a session ID. There comes one important thing we come to later as well. When you read something in the documentation, it's just the first version of truth. In the end, you always check the data if it's really like this. So for example, if I would go with it and I would work with a session ID, I could make a stop here, and then I could test the data set if it's really unique. You can simply write a SQL query to just check, okay, do I have duplicates of a session ID or not? And so this is something which I always recommend to do, especially when you introduce something to be unique, check if it's really unique. Don't trust if someone's telling you, hey, this identifier is unique. It might not. So it's tricky thing of data. And that's it. So this is what we basically do on the storage layer. What we now do, as you can see, so this is also the design thing. So you will see stuff which I might move to the storage layer. So when we move a step further, so here we start to construct the activity schema. And here what I usually do, I have two steps. So for example, I want to have an activity which is called session started, which of course is interesting for me. Could also call visit started, whatever. I usually have one step which I call prep. So there I prepare the data. And then I have a second step which in the end defines the real activity. And so we start with the prep one. And here you can already see this could be a candidate to move it down to the storage layer, or to basically take this one and move it here to make the code even better. So if I would go in and refactor things, this would be maybe, I think, the first step to do. But this is totally normal. I was just experimenting with these kind of things to get a feeling where I can get specific kind of data. And so this is why I started out here. In a refactoring, I might now, just based on principles, would move it down to the storage layer. And so what we do is here we already prepare the data for activity schema. And so in activity schema, we always have a unique identifier for each activity. In this case, I just use a random UID to do it. I could also construct this ID based on other values that I have. But this would be a whole video, how to create surrogate keys, because there are different kind of philosophies in there. What I always like to have is to have a unique ID, which is not dependent on other kind of IDs. At least really. I could also construct it from other things to achieve the same thing, but still have some kind of connections to the underlying data. But here I just went for the random one because it's totally fine. Then, for example, I bring the timestamp already here in the right timestamp format. Again, something that in the future I might definitely would do here, because in activity schema, we have a column or field which is called customer. I'm not super happy with this kind of naming. I usually, in my own variation of activity schema, I usually call it differently. So here, for example, I would call it user ID because it's closer to what we do. So I choose let's say, and we put the link down in the show notes for that. I use the real activity schema, let's say, definition. So just maybe let me quickly show that you can see it, where to find it. Activity schema, in the end, this is how the schema is is constructed. And here you can see, so this is the example how a typical activity schema table looks. And it always looks like this. Again, as I said, it makes it super easy to work with this stuff because it's always the same. So you always expect like this. And as you can see here, customer is basically like how they call the field where you put the unifying identifier. So this is what we're talking about. So we need something that unifies the activities by, let's say, a user. It can also be an account. It can be one customer. It can be anything, but usually often like you end up with a user ID here.
So on my data, I usually do data sciencey stuff. This would be like the grouping dimension, basically, that ties things together.
In event data, you usually analyze a sequence of event. And to get a sequence of event, I need one identifier that stitches these events in the right order together. So the TS basically makes the order, the timestamp makes the order, but the stitching is happening with the user ID here. And then I define the activity. So here I have the nice chance to fix improper event naming. That, for example, if I don't really have good event naming, because GA has just their own naming, because there are some standard events that are just named how GA is naming things, or maybe in the implementation someone screwed something up. So here I have the chance to just give it a new name, so just call it session started. And then I already pull, let's say, the dimensional data that is interesting for me in later analysis. So for example, I'm interested in the traffic source and traffic medium, so I pull it here as well. And I also pull the page title and the page location. And as said, this might be already something that I can move up. So I don't really have to do it here. I just did it here because I was starting out. What I also do, and again, something for the storage, I basically clean up the page location from the top level domain because I don't need it here. So I want to make it easier. So I prepare the data to make it easier to work with. So I just remove the domain name from here. And then I just finally construct the activity schema. And so in the end, I just pick all the things that I already have defined. The last thing, and so this is something which is a little bit special, I define something which is called feature JSON. And in the end, it's like when you track events, you have the attributes, property, however you name it. And this is the same thing what we do here. So we define which kind of context values are important for this kind of event. Later, when we work with the data, I will show you what kind of impact this can have and also like why it takes maybe sometimes a little bit more time to construct these things. But this is quite handy because since I save it as a JSON object, I can work with the schema very flexible. So one event, for example, can just have these two properties here, and the other one, for example, has these full ones, other one has totally different ones. Since everything is like a feature JSON, it still works in the table. But it gives me full flexibility to then later use this kind of data to, for example, create some kind of reports. And I will show you.
It's a nice mix to me. I haven't developed or fleshed out that many SQL schemas myself and dealt with schema drift and stuff like that. But it seems for me like the best of both worlds of having a general overall structure that is also extendable, but defines a certain structure. And within that structure, be really flexible by using JSON objects because you can stack it, extend it, or reduce it however the application needs it, basically.
Yeah. And this is also like a point where you can make the design decision. So I, for example, when I work on my activity schema setups, I usually don't put all the context data in here. What I put into the feature JSON is basically I put identifier for the context data, which means is like I have one table, for example, for all the traffic source data. I have one identifier like the user or like session ID or whatever, request ID, event ID. And then I put all the context information for this one into a separate table because there I want to enforce the schema. So there I want to enforce that I have this kind of values and they can have, let's say, this kind of type and so on. And then here in the feature JSON, I just put the reference in there, like the ID. This works better for me and better for my brain. And it doesn't make the setup too complicated because in the end, I might have, let's say, 5 or 6 additional dimensional tables, and this is totally be handleable. But it gives me a better feeling to not have this, let's say, cloud of things that I cannot control, because this is the downside of JSON. I cannot totally control it. So yes, I can run very custom tests against it, but it's a lot of work. So the nice thing about relational databases is like type is checked on ingestion already, like when I have defined it. So yeah.
Might be an interesting follow-up session of where now we see the basic setup, and then we can dive into more elaborate setups that brings more rigidness in the right sense, or in a beneficial rigidness.
And we will see in a second also like a little bit of the problems of this kind of approach that can occur and how to fix them. And so, for example, the approach to use identifiers and other tables is a way to make it easier to fix them. So this is session start, and then we have it already. And then I construct the next activity. So for example, here I want to have a course viewed. And I don't go into details because we already discussed it. But one thing that I want to show is this is basically, I take an event that comes as a generic event in GA. I construct a real, let's say, real event from it. So this one here is, so I use the page view event that comes automatically out of GA. So I prepare everything here. And what I do here in the final step is I use the page views, and I say every page view that has this kind of string in there, so like courses, which is like in the past, is basically a courses viewed event. And so I qualify an event into an activity. And this makes it so powerful, which I really like. I can reuse stuff that is already tracked, but I can use it in a different kind of format, in a different kind of way.
Just to get that clear for myself. So what you mean basically as a replay is when Google Analytics tracks certain things as events, you can use those or piggyback off of those events, but still like coerce it into your activity logic, basically, however you see fit, however you want.
Exactly. And then I basically just union everything. So the nice thing is, because we always use this same kind of schema, union in the end, like in SQL, means we take two tables and we stitch them together. But they have to match in this schema. So it wouldn't work if we would have different schema in these tables. And this is the nice thing. If you have, let's say, a strict, simple schema, bringing it all together is usually not, let's say, a complicated part. I can just tell you, so I worked with data models where we had really complex long tables and we were trying to union them. And this was usually like a 2-hour, 3-hour debugging session because there was one field missing. One field had a different type than the other one. So we had to align a lot of things to get it all together. This is usually pretty straightforward. So when I introduce a new activity, in the end, I just usually copy these two. And as I said, I can simplify this. So then I just copy this one, create a new one, create a new line here to union it to it, and I already have extended my activity schema. And so this is how I can extend my data setup pretty easily. And so this is why I don't have to start with everything, because it's pretty easy to enhance and to get more stuff. Then I do a final enhancement, and so we can ignore this for right now. So these are things which are helpful if I really want to write complex queries on top of this table. So for example, if I want to create a funnel query on top of this, then activity occurrence and activity repeated at are helper columns that help me to construct these things a lot easier. So this is more like, so this is optional. I just left it in because if you look into activity schema, you will see it pretty often because it's a standard way to use it. But for the things that we do right now, we will not see it. Okay, I should run this. So I hope I didn't change anything. So then
live coding always goes smooth.
Yeah. Okay, here we can see. This is our activity schema table. And as you can see, it's not wide, so I cannot scroll here. So we see everything what we need. So we can see activity ID and so on. Of course, this looks random, you cannot do. I show you one thing, which I think is still the most powerful thing when you work with activity schema. So what we could do is, so we in customer, we have a user. So we have a user ID, in this case, like a cookie ID. What we can do is we can check how these events look like for just a single user. So we basically get a snapshot of one user for activities on the platform over the whole time, or if you change the time, of course, then for different kind of times. I can do, I prepared it already here. So I just have to filter down by this kind of cookie ID, which we have here. And of course, like I order it by timestamp because like I want to have a proper sequence. So this kind of view that you will see in a second is powerful for several things. First of all, what we can see is here, it's powerful for debugging things. For example, we can have a look into, does all this make sense? And what we can see here with the timestamp and all the different kind of activities, there is definitely some kind of problem in here. And this is a known problem for GA4 data, that the timestamp, like the event timestamp that we use, is not the actual timestamp of the event.
So just to get a clear session started should become before course view. That's the thing.
And I can tell you, I ran the same query just before we did the recording and had a different kind of result. I don't know if I get the same different kind of resource because it might be cached now. But when I ran it before, for example, it started out with a session start and then course view come. There's this problem that basically Google is setting the timestamp when they send down the batch of all the events to the system, which is ridiculous. And it opens up the next chapter where we can rant about Google. So one thing, if you want to work with this stuff, is set the timestamp yourself when you track the Google data, because it doesn't really create a lot of chaos, but it can already. So for example, if I want to create a proper funnel, then this can already be difficult to do. This view to see a sequence of events for just one user or for one cookie ID gives you the ability to debug things pretty quickly.
And so it would have been really hard to do, I think, by working on the nested data from the get-go, right?
Yeah, of course it's possible. Yeah, you can identify one, then you can try to get the ID out, and then of course like you can do, but it's still a lot of noise. So this is the problem when you would try to do this on this kind of data. So of course like you can get, I don't know where the pseudo ID is, somewhere. So of course you can basically filter by this one, then order it also like by the event timestamp, but you have too much noise here. So the other kind of, let's say, this kind of output makes it a lot easier to work with it. And what we can already see here as well is like that session started, how I constructed it, doesn't really seem to make sense because like I have too many session started events here. So it gives me another ability to debug. And so I can make a different decision to say, maybe I have to construct session started differently. So it gives you a possibility to really design things that they fit in the end. We leave it like this. So this is our version 0.4. So not maybe something that we feed into reports, but it's our first step. But this is it. So this is already the one table that we create. And as a final step, I can show you how you can create, let's say, a final table that you can then use, for example, something in Looker Data Studio and so on, or any kind of BI tool to create some charts. I create a classic one big table where there are enough people on this world who don't like one big tables, but I like them especially for reporting, if I have a very static reporting. So if I have a reporting, you have a Tableau background as well. If I have a lot of reporting where I need to really like to deep dive into things, want to add a lot more dimensional data, so then I could also do it as a star schema, because this works pretty well with BI tools. But for example, if you use something like Looker Studio, then you usually have pretty, let's say, static kind of things. So you don't really need a star schema. So one big table is really nice because like you have one table where you have dimensions and metrics. And that's what I do here. In the end, what you just saw here, I saved this query. So you can save a query in BigQuery, as you can see here. And you could even schedule it. So I could even schedule it. So I could save the query first, and I schedule it to run it every night. This is our first step to make it really, let's say, scalable and automatic. So I could save it and run it every night. And then I can run a second query on top of this data and then generate the final reporting data.
So something that jumps to my mind when I hear scheduled, I'm assuming that what you just showed is like the very first step of a 0. Whatever setup. When you need to schedule things, you need to orchestrate things. So I'm assuming that the way you actually will do it in production is to use something like dbt or Dataform or whatever, and that we jump there either today or in the next session.
I will give a quick insight into how to do with dbt, but you don't have to.
Mm-hmm.
So since we are just talking maybe about 3 queries or 3 model queries that we run, these are easily scheduled. Yep. So you can schedule the first one on 1 a.m., the second one on 2 a.m., and the third one on 3 a.m. to have totally enough time in between that you don't run into overlaps, because this is the only problem, that if you manually schedule things that you can, of course, like the one can take longer than the other, and then you don't have fresh data. Or weird data, because like stuff is already ready, but not totally ready. For this kind of approach, let's say normal schedule still works. And here you can see this is the schedule button. So I could now press it and just schedule the thing. And this is like how I started out with my first data models. So the first data models that we created were not really complicated. And we had 5 or 6 queries just scheduled in BigQuery. And we went with the setup, I think, for over a year. And it was okay.
But that's fantastic. What I see, and I'm guilty of that myself a little bit, is to jump to tools too quickly. Because tools always, any tool that you bring into the pipeline adds additional overhead. And as long as you can get away with the pragmatic solution that works, and you just showed one, that's fine. And once you outgrow that, then it's the time to actually look into the next step up in the tooling chain.
Yeah, that's right. And just to show you what you can now do with the data. So as you can see here, so I persisted what we just did here. I persisted this in this kind of table. So I now access the table directly. The data that we see here, I now pull in here. And so here you see the nice thing about the JSON stuff. So it's pretty easy for me to access these kind of values, even when it's pretty flexible. So what I do now is I take the timestamp, qualify it as a date, because like usually reporting data has the granularity often on a date, not on a timestamp level. So I bring it some levels up, and then I basically pick this dimensional data. So like course, traffic medium. And of course, I also want to have the activities because I use the activities to construct the metrics. And then in the final step, I just construct everything. So I keep the report date, I keep the course as dimension, then I keep the traffic medium as dimension. And then here I construct simple event count metrics. So these are event totals for sessions started and event totals for courses viewed. And of course, this can be now extensive. So whatever kind of metrics people need, we can prepare them here. So for example, we could also create a unique courses viewed. So unique means in comparison to total, I just want to have one count for one user. So if a user looks into 5 courses, so then the total, we see the 5, and in the unique, we just see 1. So which is a standard thing in GA4 as well. So I can construct it here as well. But I start with something very simple. I group everything because I aggregate stuff here. So of course, like I have to group everything because this is an aggregation function. And then in the end, I just bring it out. If we look into it, then we already see also like some interesting stuff. So now we basically have something that we can put into Looker Studio. One interesting thing is this is, I explained it a little bit like with this feature JSON thing. We don't have all the context for all the events. For example, courses viewed event doesn't have any kind of idea about the landing pages that we have defined here for the session started, and vice versa. So like the session started don't have any kind of idea about the course that will be shown.
So it's a nice decoupling, basically, what you realize. Mm-hmm.
And so this, for example, is like why this information about this course is missing, which is totally fine because like I can still use this data now. Looker Studios, for example, I can use the session started metric with this kind of dimension to, for example, then show a breakdown of how many sessions has been started on this kind of day and from which kind of traffic source they were coming. I can show next to it, because like it uses the same kind of table, I can now choose which kind of course has been viewed. So here, but it doesn't really, so yes, it has. I don't know, I think I did some fixes that it already also, no, the traffic medium is still there because like it's on a session level. But for example, I couldn't use the landing page for it by the current design. I could work on the design or on the setup here to enable this as well. So for example, to stitch session information with the course viewed event to then access this kind of information as well. But then I just change the model. And this, for example, brings us to the point where I use the slightly different way, how I use the feature JSONs, because it makes the stitching of context data a little bit easier, at least for me. But right now, we can already create a chart, for example, like which kind of courses has been viewed on, let's say, in the last week with a bar chart, and we can use the information because we have it here. We might have to clean this up a little bit. So like we have to get off URL parameters. You might have kick out the courses so we can clean up the data a little bit better. But this is already data ready for reporting.
Mm-hmm. Can I just maybe ask one question? Because when we look at the column of traffic medium, there in the upper part there's a referral where the course column is empty basically, and then there's a referral column where you have course information. This is basically because for the first, what is it now? It's two days also. This is like a different view in the first part where the course cells basically are empty. This is looking at some other aspect, or it's another event or another activity than what's listed below where you are interested in the courses, which courses are viewed. Am I correct in this?
You're correct. And one thing that you have to keep in mind is a user can view 5 or 6 courses, let's say with one traffic medium. And then maybe at some point they go somewhere else and they come back and then they have a different traffic medium. So these things are not really connected. So this traffic medium is connected to session started. Mm-hmm. And this traffic medium is connected to courses.
Okay, got it.
And for example, if I really want to see where, let's say, the users are coming from when the session is starting, I would use, let's say, traffic and session started in combination. And then, but still, like for courses viewed, I can still analyze where originally they were coming from. So still useful.
I really like it. I actually have not seen, because I haven't worked with this schema in one big table that much, but I do see the benefits of you can actually bring together aggregated data that is structurally really different, still bring it together in one table, not having to jump between tables, especially when you actually want to construct reports on top of it with Looker or Tableau or whatever.
Yeah, you don't want to have so many joins there.
Yeah,
so
exactly.
At least I want to avoid joins. So here you don't need joins. You just put it like this. That would not be my end state, because again, like user experience or developer experience is not super great. So you have to know one or two things to work with this stuff, which is okay in a lot of setups, but in a bigger setup can become problematic, because like it can create a lot of question marks, or it can make people do things they shouldn't do.
There's no free lunch, right? So there's always downsides, but as long as you stay in the more pragmatic solution that gets you somewhere, I think this is like a viable solution for your reporting layer.
Yeah, and it especially like it's a very quickly created kind of solution. So I might work on this to make it, let's say, a little bit more streamlined and so on, but this would be, let's say, my next session when I go into it to clean things really up. But the good thing is this is already a deliverable. So I can now go in and create this first dashboard where I have these two metrics and, let's say, dimension, and then present it already to the team. And then they might come back and say, okay, we also need traffic source. When I say, yeah, no problem, then when we need traffic source, what I do is so we have traffic source as a general thing. So traffic source is another value from it. I have it here, for example. If I wouldn't have it here, I could just introduce it here, then save it as a feature JSON, and then in the end, just pull it out here as a dimensional value. Extending this kind of setup to produce a new metric or new dimension is usually pretty straightforward.
Yep.
And this gives you this freedom to really start on a small scale and not really go, let's say, I want to keep everything in there to be ready for every use case. No, it's pretty simple to just, extend what you have. Final thing, so before we wrap up, if you then at some point think, okay, maybe I really need to manage it differently, just have a quick look how this can look like in the DBT setup. So I have to fire this up again. This is a classic DBT setup. If you worked already with DBT, what is DBT? DBT, let's say, I make it a really simple version, is like a SQL orchestrator. So what it enables me is I can split up what we just did in one or two queries. I can split it up in, let's say, more queries and just stitch them together. So here we do the same thing. So we have basically here's like my storage layer or source layer. And here I do the same thing, what I just showed you in the query. I prepare everything. So I would now move some logic from the stream layer, which I have here, where I construct this. So I would move now some stuff here down to the storage layer to not have to do it all the time. And then in the end, I have a reporting layer where I create my one big table. So I also use the folders then in the way how I use the layers. But in the end, like people have different approaches, how they structure the DBT project. But now the nice thing is like, what I can do is now I can basically just do, let's see if this works because I haven't tested it before. So I could now, let's say, do a DBT run. And DBT run does the same thing what we just did manually in the BigQuery editor console. It does the same thing what we did manually now automatically in program. It basically runs all the queries that we ran before. It just the only thing what it does. So for example, here it creates a view. And for the final two things, it creates a table to materialize it.
And it probably adds checks and balances of making sure that you cannot continue with the next step until the previous step has been materialized and so on and so forth.
It helps a lot that I don't have to do this, let's say, scheduling jeopardy, which can work for 6 queries, but maybe not for 10 or 15. So here I can just, so as you can see here, maybe just quickly show you, I reference tables. I don't write the actual table, I just reference another model or query that happened before. And by that, DBT knows in which kind of order they have to execute it. And so you can see it executes it in this way. This makes it scalable. This makes it a production setup because I can just run DBT every night. And you already mentioned it. I can now also hook up some tests in between. So I can check data integrity along the way to make sure that I don't introduce weird stuff and so on. So it can give me, let's say, a lot of possibilities to work with these things. So this makes it really powerful. Okay, but this is not about DBT, so let's go back to BigQuery. And you could also use Dataform. So Dataform, as you can see here, is basically the BigQuery DBT. They reintroduced it some months ago. I still use DBT because I invested a lot of time into DBT. If I would start new, I'm pretty sure that I will stick with BigQuery. Dataform is definitely a good option as well. Of course, I'm biased because
maybe we do a comparison by DBT and Dataform one day of where the actual benefits lie.
But we should have the right people. So we should have people who invested a lot of time in Dataform and someone who invested a lot of time in DBT, because they are flavors. And so, of course, if you're used to a flavor, you usually stick with the flavor. So if I look in Dataform today, and I did it already, I will complain too much because I'm like, why do they do this like this? Where in the end, someone who basically invested with Dataform will be super happy because they say, no, it's working on totally fine. So
that will always be that way. But what I would like to see is more formats of doing one use case like for like.
Yes.
How would you do it this way? How would you do it that way? Then people can still decide. I'm the same way. For me, DBT versus Dataform would translate into R versus Python. I do program more in Python, but I keep missing stuff that I know from R and love in R. Yeah. And it's like the same thing. And this is all over the place, right? And maybe just a thought of a new session that we could do someday.
It's a good new session idea. Okay, that's everything which I can share for today.
Nice. It was really informative for myself because I'm not that, my daily business is not dealing with data and web analytics setups and the tooling around it. And I get out of this session actually understanding quite a bit more about how things are structured, where the downsides were or are with Google Analytics 4, and how you can mitigate it in a really pragmatic manner before jumping the gun and doing the big bang data model that rules the world or data schema that rules the world. I think this was really informative.
Very good. I hope this is also the takeaway from me. You don't need a data model if you just do some ad hoc stuff. At some point you might need it, and then also do it as simple as possible. Don't go for a big solution. Don't spend too much time on a whiteboard to sketch out how a data model should look like. Find a way where you can scale it, and then also handle it in the way. Don't only use the things that you really need. So don't go for, I might need this dimensional values as well. And look into activity schema, because especially for event data, activity schema from an operational level can scale really good. So I have setups that I work with, and I always love to go back to this kind of setups because I know that I can extend it in 2 hours. And not in other models, and because I don't work constantly on the same kind of things, because when I do consultancy work, it's not like that I always work on the same stuff. If I go into other models, it usually takes me 1 or 2 days to get a grasp what I want to do. And here it's a no-brainer thing. I always know where to patch things. So.
And that's really, you outlined this perfectly in my sense. That's one of the most underrated things still, is reducing the time it takes you as an expert, data science expert, programmer, to actually wrap your head around the use case again, to actually become productive. It's a big difference if it takes you 30 minutes or 2 minutes, because your entire mental model is streamlined on this one thing, and you still can extend it when you need it. I think this is a really underrated thing still, and people should focus more, because there are lots of productivity gains that lie there. Awesome, Timo.
Thank you.
So thanks for the session, and catch you in the next one, hopefully.
Yeah.